Today, we are understanding phosphorus from a monitor's guide to water quality. So first of all, what is it? Phosphorus is an important nutrient for plant growth in lakes and streams, and phosphorus can be dissolved in the water, attached to particles floating in the water, and found in bodies of all living organisms. And different forms of phosphorus include total phosphorus, which is a measure of all that includes different forms, orthophosphate, also called phosphate, and the related soluble reactive phosphorus. Now, orthophosphate or phosphate is the most bioavailable form of phosphorus, meaning is most easily used and taken up by organisms that live in water. Things like sewage, agricultural runoff, and fertilizers can contribute to higher levels of phosphorus in the water bodies, and phosphorus can also come from the erosion of rocks and soils from decaying organic matter. Now, you might be thinking, okay, that's fine, that's good information, but why does that matter? So, algae and aquatic plants need phosphorus to grow. However, there doesn't need to be a lot available phosphorus to support normal growth in aquatic ecosystems. In lakes and streams that receive extra phosphorus, algae and plant growth can increase to the point it causes problems like algae blooms, reduced oxygen levels, and fish die-offs. And phosphorus entering a lake may eventually get deposited in sediments at the bottom, and this phosphorus can then get released into water for many years to come. And they refer to that as internal loading. And for this reason, it can take several years of reducing phosphorus inputs to a lake before we see reduction in harmful algae blooms, or commonly known as HBAs. Now, what is phosphorus loading? This refers to the amount of phosphorus entering a lake or river over a period of time, like a year. And it is important to manage phosphorus loads to ensure that lakes and waterways can function as good habitat for fish, bugs, and other organisms that live there. We can see the phosphorus cycle from various natural and human sources for inorganic phosphorus, organic phosphorus, uptake by animals, uptake by plants converted to organic P, death. We can see excretion right here, and decomposition. And once it enters a lake or stream, it's often contained in a closed loop. And increased phosphorus loading contributes to eutrophication, and eutrophication happens when a body of water becomes overly enriched with nutrients, often due to runoff from the land, and this leads to excessive algae growth or algae blooms. And when a bacteria consume decaying algae, they use up the oxygen in water, causing low oxygen conditions that are harmful for fish and other aquatic life. And some types of algae include cyanobacteria, also known as blue-green algae, and can make people and animals sick if they come into contact with it. Now, how do you measure it? Well, it's measured from a water sample that's sent to a lab. The water sample may or may not be filtered before the analysis. This determines in part what form of phosphorus is being measured. Particulate phosphorus is that portion of the sample that's held back by the filter, so it's important to record and report this information with the results. And different forms of phosphorus behave differently, and they can have different impacts on water quality. So it's important to know what form of phosphorus is being measured. Also, some form of phosphorus can be also estimated using test strips that change color when placed in the water. And the color is evaluated against a guide to determine the approximate phosphorus concentration. So that is very good information from DataStream. As I said at the end, you need to get a sample to the lab to really understand what's going on with the level of phosphorus.